Hi guys, welcome back to the channel. So today we are going to be solving today's lead code question, which is remove k digits. So we are given a string which is num, and then we are also given one more integer which is k, and then we need to remove these k digits from the num so that we'll get the smallest positive possible integers after removing k digits from this particular number. Suppose let's take this particular example where we have a string will be this 143 and then 2 and then 1 and then 9, and then we need to remove k digits equal to 3. So suppose if we want to remove this particular k digits equal to 3, then we can do with a different approach. Suppose let us take like uh, for each case we'll try to remove this particular digit, or we'll keep it in the string. So suppose let's say we take one from this particular string and then two and then nine. So this is going to be our one possibility, and then we are going to pick three more digits in this particular string, and then we will be removing that, and then the other the other numbers which are present in this particular string are going to be our answer. And out of all those particular answer, then we are going to pick the smallest possible integer after removing these three digits. Suppose let us write some of the cases. If I remove first three elements, then it is going to be 2219, and then let's say I remove 432, so then it is going to be the digits is going to be 1219. Suppose let's say I remove 322, then it is going to be 1414 and then 19. So and then we'll try to remove all the three digits, and then we are going to get the list of numbers which are present, and then out of these particular list of numbers we are going to pick the least number. So if we try to do that particular case, then we are going to get the more time complexity, which is not optimal. So let us try to optimize this particular solution. So let us say that this particular num's length is n, and then now we want to remove k digits, which is going to be k. So after removing this k digits, it is going to be a length of n minus k. Suppose let us take this particular example. For this particular example, if I try to remove three digits, then there can be different answers. Suppose let us pick the largest element and then try to remove this particular case. Suppose if I remove 9, then it is going to be 1 4 3 2 2 and then 1, and then I'll again remove 4, and then again I'll remove 3. So then it is going to be 1 2 2 and then 1. So and then if we see this particular number, this is a smallest number. But if I try to remove 432, then it is going to be like 1 2 and then 1 9, which is less than this particular 1 2 2 and then 1. So if we try to observe this case, so we have 4 and then this particular 4 should is greater than this particular 3. That means this particular digit is the most significant bit. Suppose whenever we remove three digits, then the element which is present to the left is always be the most significant bit. For that most significant bit, we are going to reduce that particular most significant bit. Suppose if I take 1, then instead of considering 1 as the first element, if I consider 4, then it becomes more. So let us take only 1, and then again we'll take 4. After taking 4, suppose let's say I remove 4, and then instead of 4 4 place, if I keep 3, then it is going to be much lesser number. And then again we have 3 and then 2. So instead of keeping 3, if I keep 2, then it becomes much lesser number. And then we had used k twice we had used, so it is going to be 3 minus 2. Now we have k equal to 1. Now again we have 2, so instead of keeping 2, if we keep 2 again, then it will be same as well. So let us take next number, next digits, which is 1. So if I keep instead of 2, if I keep 1, then it is going to be much lesser number, so I'm going to keep this one, and then at last we are going to keep on 9. So this is going to be our answer. So we'll be returning this particular string which is present now. So for this, if you want to remove the numbers which are present at the most significant bit, we are going to use the stack where it will store all the elements, and then those elements will be stored based upon like it will be in increasing order, like 1 2 3 and then 4. And then whenever we face like any number which is 3, then instead of considering this particular 4, we are trying to will remove this particular 4, and then we are going to use this particular 3, so that dis- uh, the number most significant bit will be reduced. And then let's say after completion we have k equal to some 5. Suppose let's say we have 4 and then 5 and then 6, after traversing through the stack, and then we have 7, and then now we are left with k equal to some 2. Now we need to remove two elements from this particular string. So if I try to remove this particular 1 2, which will be like 3 4 5 6 7, which will be larger. So we'll try to remove from the last itself, so that these are the largest numbers. If we remove this particular largest number, then this becomes lesser. So let us go through the code. So for this we are going to consider remove k digits, and then we are going to have num equal to num and then k, and then we are going to take the stack string which is st equal to empty as of now, and then we are going to take I equal to 0, and then we are going to traverse till the end of the string. And then let's say we have k which is greater than 0, that means we have the chances to remove this particular digit. Then let's say this stack is not empty, and then stack dot back is greater than this particular number. Then instead of considering this particular bit as our most significant bit, we are going to consider this particular bit as our most significant bit, and then we are going to remove this particular digit which is present in this particular stack, and then we are going to decrease k. And then after that, let's say suppose if it is not empty, or it is not equal to 0, then we are going to push into the stack. Suppose let us consider one case where we have 1 and then again 0. Now we will remove 1, and then we'll have this particular 0. Suppose if this 0 is doesn't have any particular value, that is, this will be empty, like nums of I will be like 0 digit and stack will be empty. For that particular case, we will not be pushing this particular 0 which doesn't have any value. So that's why we are going to check this, and then we are going to increment this particular array. At last, let's say we have not empty stack, and then we have still the digits need to be removed. So we'll remove from the back of the stack, and then at last we are going to remove this particular stack. If it is empty, then we are going to give it as 0 value. If it is not empty, then we are going to give it as particular string stack. Yeah, that's all for this video. And then if we come to the time complexity, it is going to be big of n, and then space complexity is going to be big of n. Why? Because we are considering new stack which is string stack. Yeah, that's all for this video. Thanks for watching.